Types of routing protocols: static, dynamic. In dynamic routing protocols, we have this many: RIP, EIGRP, OSPF, and BGP, ISIS, right? So RIP is going to work on the distance vector routing protocol, and EIGRP stands for Enhanced Interior Gateway Routing Protocol. It is going to work on the advanced distance vector routing protocol. So when the EIGRP is going to calculate the metric, it is going to be involved bandwidth, delay, like it's a composite metric. Metric equals to composite metric. The composite metric terms are bandwidth, delay, load, reliability, and MTU. Bandwidth, delay, load, reliability, and MTU. The default MTU is 1500. So in routing protocols, so the similarities, we discuss about the similarity about the routing protocol. So every routing protocol will have a similarity, right? What protocol it is going to be used, and the algorithm, multicast address, administrative distance, hello and dead timers, port numbers, load balancing. So we compare between the RIP and EIGRP, what features we have, what advantages we have, and what disadvantages we have. Then we discuss like in detail about the protocols. So generally we have three protocols: static routing, dynamic routing, and default routing. Dynamic routing is again classified into two different protocols. One is IGP, Interior Gateway Protocol, Exterior Gateway Protocol. IGP, these are all the protocols we have: RIP, EIGRP, OSPF, and ISIS. Respect to that, followed by the protocol, which protocol the protocol is going to be used, and the AD values we discuss here. And in BGP, we have IBGP, internal BGP, and the external BGP. Within the AS autonomous system, we are going to run the IGP protocols. Within the autonomous system, we are going to run the IGP protocols, these protocols, and to communicate different autonomous, like between two different autonomous systems, we are going to run the BGP, Border Gateway Routing Protocol. And then we discuss about the syntax to configure the EIGRP on the routers. Okay, to configure the EIGRP in the routers, this is the syntax. Like first, you need to go to the configuration terminal mode, then enable the routing process with the help of IP route command. Then router EIGRP, the AS number, you need to mention the AS number 100, 200, 300, like. Then network space, network ID, and the wildcard mask. So what is wildcard mask? Wildcard mask is the inverse mask of the subnet mask, and we have the formula also to calculate the wildcard mask. So wildcard mask equals to global subnet mask divided by the actual subnet mask. Global subnet mask means all 244, 255.255.255. So when we are going to calculate the wildcard mask from the actual subnet mask, for the class C we got the actual wildcard mask is 0.0.0.0.255. And we have taken this scenario. This is our scenario. So in this scenario, we taken two routers, and for router 1, the LAN network is 1.0/24, and for router 2, the LAN network is 2.0/24. And we connected both the routers with the point-to-point link, and we have taken 172.16.1.0/24 network for the WAN connectivity. And 1.1 we assigned on router 1, and 1.2 we assigned on router 2. So the same thing we configured with the help of syntax. So we just enter into the configuration mode, then we enable the routing process, then followed by the syntax: router EIGRP, AS number, network space, network ID, and the wildcard mask. So if you have multiple networks, you need to repeat this command multiple times. So in our scenario, we have two networks. One is 1.0 for the LAN, and for the WAN purpose, we have 172.16.1.0. Even in router 2 also, we have 2.0, one network, and the two networks. So we repeated these commands, and we understand about how many tables EIGRP is going to be maintain. EIGRP is going to maintain the three tables, right? Three tables. One is neighbor table, second one is topology table, and the last one is routing table. So neighbor table will contain the information of directly connected neighbors. So if you check the RIP router 1's neighbor table, you will see this three router information because these routers are directly connected, but you will not see this router information because it is indirectly connected. To verify the routing table, the command is show IP EIGRP neighbor, show IP EIGRP neighbor. And to verify the topology table, so the topology table will contain the information of whole topology, the complete topology. R1 will have information of route 2, route 3, router 4, and router 5 as well. So to check that routing table, like the topology table, the command is show IP EIGRP topology. And the routing table will contain the information about the best route towards the destination. To verify the routing table, the command is show IP route EIGRP, show IP route EIGRP. And we discuss about the AS as well, autonomous system number. We have total AS number 65,535. So out of 65,535, so the AS are again classified into two types: public AS and the private AS. The public AS range is 1 to 64,511, and the private AS will start from 64,512 to 65,535. So this is what today we discussed. So tomorrow